students, today's lesson is on compound events. Before we get into compound events though, let's do some key vocabulary with sample space. Sample space is the set of all possible outcomes of one or more events. And if we have more than one event, we can use a table or a tree diagram to find the sample space or the number of possible outcomes. So let's look at our first example. Let's say we're going to a pizza place and we're going to randomly choose a crust and a style of pizza. We want to find the sample space or how many outcomes there are. We see that there's 2 different crusts offered and 4 different styles of pizza. So we're going to make a tree diagram. We're going to start with thin crust and stuffed crust. And if I order a thin crust, I could get 4 different styles. So I could get Hawaiian, Mexican, pepperoni, or veggie. So that's 4 different outcomes right there. I could get a thin Hawaiian, a thin Mexican, a thin pepperoni, or a thin veggie pizza. Same choices apply with stuffed. I could get Hawaiian, Mexican, pepperoni, or veggie. So that's 4 more outcomes. So that's a total of 8 outcomes. All right, now, another key idea here is the fundamental counting principle. This is another way to find the total number of possible outcomes. And what the fundamental counting principle tells us is that if one event has m possible outcomes and another event has n possible outcomes, the total number of outcomes of m occurring and then n also occurring would be m times n. Now, if we look back at this example where we did the tree diagram, notice there were 2 kinds of crusts and 4 styles of pizza. 2 times 4 is 8. We get those 8 outcomes by doing the tree diagram or also by using the fundamental counting principle. So let's practice using the fundamental counting principle. Here we have, if we are going to roll a number cube, a 6-sided cube, and flip a coin, what are the total number of possible outcomes? So here's a table first to show us all of the different outcomes. We could make this table and see if we roll the cube, there are 6 possible outcomes, rolling 1 through 6. And if we flip the coin, there are 2 possible outcomes. So that's a total of 12 outcomes. I could roll a 1 and get heads. I could roll a 2 and get heads. I could roll a 3 and get heads, etc. We can also use the fundamental counting principle. If there's 6 outcomes for the number cube and 2 outcomes for the coin, that's a total of 12 outcomes. Okay. Let's look at another example. We're going to practice using this fundamental counting principle. How many different outfits can you make from the t-shirts, jeans, and shoes in this closet? So let's look at how many outcomes for each event first. So t-shirts, we're going to count. There's 1, 2, 3, 4, 5, 6, 7. So we're going to write this down. 7 t-shirts. And then we're looking at jeans, and it looks like we have 1, 2, 3, 4 pairs of jeans. And then shoes, we have 1, 2, 3 different choices of shoes. So if we want to know how many outcomes we have, how many different outfits we could make, we're going to multiply 7 times 4 times 3. And we get 84 possible outcomes. All right, now let's get into this idea of the compound event. So a compound event consists of 2 or more events. As with a single event, the probability of a compound event is the ratio of the number of favorable outcomes to the number of possible outcomes. It's just a little bit more complicated because we might need to use that fundamental counting principle to find out the number of outcomes, which we now know how to do. So let's look at our next example. We're going back to the same idea of flipping or rolling a 6-sided die and flipping a quarter. What's the probability of rolling a number greater than 4 and flipping tails? So we know that our probability is going to be the number of favorable outcomes to the total number of outcomes. And we already counted that there were 12 total outcomes. 6 times 2 gave us 12. Now, I'm going to go back to that table so that we can look at that, so that we can see how many of those outcomes had a number greater than 4 and tails. So let's look back there for a minute. Okay, so a number greater than 4 means it has to be 5 or 6 and tails. So we're looking at 5 and tails, 6 and tails. So that's 2 favorable outcomes out of the 12. So 2 out of 12, we could simplify that to 1/6 as a fraction, or 16 and 2/3%. If we're going to the nearest whole percent, we could say 17%. We could say 16.7 if we were going to the nearest 10th, depending on how we want to round that. But about 16, or exactly 16 and 2/3%. All right. Now, let's look at one more example of finding the probability of a compound event. So let's say you flip 3 nickels, and we want to know what is the probability of flipping 2 heads and 1 tails. Not necessarily in that order, but out of the 3, 2 of them are heads, 1 of them is tails. So let's go ahead and make a tree diagram here so that we can see all of the different outcomes and what they are. Because we could use the fundamental counting principle to find out that there should be 8 possible outcomes, 2 times 2 times 2, but we don't know how many of those are 2 heads and 1 tail. So let's start by saying the first roll could either be heads or tails. The second roll could either be heads or tails. And then the third roll, heads, tails, heads, tails, heads, tails, heads, tails. Okay, so let's look at the overall results. If we go this route, that's heads, heads, heads. That's not one that we're looking for. That is not a favorable outcome. Here we have heads, heads, tails. We're looking for 2 heads and 1 tail, so that is a favorable outcome right there. Let's look at our next one. We have heads, tails, heads. That's also 2 heads and 1 tail, so that's a favorable outcome. And then we have heads, tails, tails. That's too many tails, so that is not a favorable outcome. Now let's look down here. Tails, heads, heads. That's 2 heads and 1 tail. Tails, heads, tails. That's too many tails. Tails, tails, heads. It's also too many tails. And the last one is way too many tails, all 3. So there are 3 favorable outcomes. So our probability of flipping 2 heads and 1 tail would be 3 out of 8, or 37.5%. All right, that's it. Go ahead and try a few on your own. I'll see you soon.